Hi guys, Sajjad Hussain again with a new video. In this video I am going to show you how to transfer data from SAP 2000 to CSI SAFE to design the foundation and design the slabs. I shall use one of my previous videos. In that video I took an example based on PCA note ACI 318 and the example was 11.2. In this example the structure was a 12-story building and the plan was there were 5 bays in X direction and there were 3 bays in Y direction. All these bays are at 24 feet. The slab thickness was 7 inch. Other parameters were like beams. All the beams were 24 by 20 inch. Exterior columns were 22 by 22. Interior column were 24 by 24 inch. Superimposed dead load was 30 pound per square feet. Roof live load was 30 pound per square feet. The floor live load was 50 pound per square feet. Lateral loads were not defined properly over here, but in my example I consider the lateral load. I use the lateral load generator, that means I use the wind load generator and I use the seismic load generator to generate the wind and seismic load on this structure. Let me show you the loads which I considered. The load cases were dead load, modal, superimposed dead load, live, roof, earthquake in X direction, earthquake in Y direction, and there were 12 cases of wind load. These 12 cases of wind load were generated by SAP 2000. Now let us run this model. Model is, we are not going to run the modal analysis, so I said do not run. The rest of the loads are used in this model, so let's have a run. So run is finished. Now let's go to file, export. Let us export in the format of SAFE F2K. Elevation is 0, 0, that means the base reactions. All the loads above an area, etc. Let us select the load cases. Let us select all the load cases. Okay. Let us save this file here in foundation. Yes. Similarly, we can export the level at 15 feet. Let me show you what is 15 feet. 15 feet means when Z is 15, this is the first level or the first floor slab. So let us export. Level is 15. Let us select all the load cases. Okay, and we should save this file in slab subfolder. Okay, now we can close SAP 2000. It's no more needed. We can let it remain open. Let's go to SAFE. Let us import. Let us import the first foundation input data file. So here is the plan at level 00. We will define material. Concrete is 4000 psi. Okay, we are not going to change it. Reinforcement is A615 grade 60. Okay, we will not change anything over here. Let us define the slab properties. Let us rename it as foundation slab. Let us assume a thickness of 33 inch. Okay, let us define column properties. We know there were two sizes of the column. There were interior columns, so let us say this is column interior. The interior column with 24 by 24 inch above the ground, so below the ground we have to have little larger, so let it be 30 inch by 30 inch. Similarly, we can say column exterior. These columns are 2 inch smaller, so let it be 28 inch by 28 inch. Okay, now we can draw the foundation. This is the quick foundation. Type of object is slab. Shape of the object is rectangular. Either we can select rectangular or circular, so we will select rectangular. Property foundation slab as we defined. Dimension in X, so for interior let us assume 18 feet by 18 feet. Okay, trim at slab edge is not needed, so let it be at the default, no problem. So let us draw these slabs. Interior 1, 2, 3, 4, 5, 6, 7, 8. Then we will draw little smaller slabs, 16 by 16. Let it be here 1, 2, 3, 4, 1, 2, 3, 4. Then we can reduce further. Let it be 14 by 14. Let us assign at these locations, and we can further reduce 12 feet by 12 feet. Let us assign at these 4 corners. So we have defined the slab. Now let us define the column. Here type of object is a column. Column property of the column below, no, none. Property of the column above, interior, height below, nothing, 0, height above 6 feet, and that's okay. So these are the interior columns. Let us define here 1, 2, 3, 4, 5, 6, 7, 8. Then let us define the exterior columns. Below none, above 6, that's fine. So here are the exterior columns. So our geometry is done. Okay. Now let's have a 3D look. From here 3D you can see that the center point is still defined as fixed support, and here at the top it is also restrained in two directions. So let us delete these support conditions. Let us select all, and let us assign support data, point restraint, nothing. Okay, gone. Now we will define the subsoil properties. Let us select all slabs, and let us see subsoil parameters. These are modulus of subgrade reaction is 1.728 into 10 raised to power 5 pound per cubic feet. Let us assign this default value. We are not going to change anything. Select all slabs, assign soil properties slab 1. Okay. So now the support conditions are defined. Then we can have a look for the loads. All the loads are there. We can define the load combinations. Default load combinations is strength, yes. Ultimate load combinations are there. Service initial, we are not interested. Service normal, yes. Service long term, we are not interested. Okay, so all these load combinations are there. Let's see the first one. Only dead load. All the dead loads are combined, dead, live, etc. So that is the load case we were looking for. Rest all the load cases are ultimate load cases that will be used in design. That's fine. So if any more load cases we need to define, we can edit over here, we can add, and we can define as per our code requirement. For the time being, just for demo purposes, let us stick to the default load combinations. Let us save the file. Now we have to draw design strips. In A direction, let us define this is the A direction. So these are layer A. Now similarly we can define layer B. Okay. So we have defined all the layers. Let's save the file once more. Now let us run analysis and design both. let us display the deformed shape for load combination N2. Okay, so for load combination N2, the deflection is in inches. This is 0.4 inch, 0.4 inch, 0.4 inch. These are very small, so the deflection is not even an inch, so we can take this value. And now let us show the reactions for load combination N2. Soil pressure, the soil pressure is little higher over here, 5.7 kip per square feet. That was our data, so we are not going to change anything. Let us assume that the soil bearing pressure, the allowable soil bearing pressure is higher than the value over here, and our design is safe. Suppose if the soil bearing pressure is higher than the value shown over here, we can increase the size of the foundation. So maybe we can go for second run, but for the time being, for demo purposes, I am going to take these values. And let us display the design. The design basis is a strip, both layer A and B. Let's show the bars. Apply. So you can see all the bars are shown over here. You can check in details. There are how many bars are there. For example, number 15, there were 71 bars. We can control whether we can increase the size and we can reduce the spacing. Everything is possible over here, but for the time being, let us take these values which are by default. Let us check the punching shear. Show the punching shear. Slightly higher punching shear we can see in the middle. These are 1.04. It should be less than 1. So what we can do, we can increase the thickness. Let's have a second run by increasing the thickness. Define soil properties. Let us change it to 36 of an inch. Okay. Let's see the design preferences. Code is ACI 31808. Minimum cover is 3 inch. Preferred bar size, let it be 8. Okay. Let us save this model, run analysis and design. Let us go to punching shear check directly. Still it is little bit higher. Maybe we have to increase the thickness little bit, but anyway, for the time being, let it be like this. Or one more run. Let's have a look. Slab properties. Instead of this, say 39. Okay. Let us display the punching shear. Now this is lower than 1, so this thickness is okay. Let us display the slab design, both A and B Now our bar should be minimum 8. Apply. So here you can see the bars are shown. So this looks an adequate design. We can use this design as our drawing. Now let us run the detailing. Okay. So the detailing is done. Let us see drawing sheets, bottom bars. These are the bottom bars. These are the bottom bars shown. Let's see the slab sections. These are the sections. So very helpful to develop our IFC drawings. Only some minimal CAD effort will be needed to develop IFC drawings. So this is the way we design foundation in SAFE 2016. Hopefully you will like this idea. Now let me close this one and show you how to design this slab. Let me close this one. Let us have a new model. Save, yes. Let us import again. Save F2K. This time I will import the slab data file. Here is the slab data file. Now you can see the slab data file is transferred over here. Let's see the forces, etc. Load cases, all the load cases are here. All the load data is transferred. So what we have to show, we have to draw the design strip. Let us define the design strip. Design layer A. Okay. So the column and mid strips are defined over here in Y direction. Now similarly for layer B, we can define the layers. We can define the design strip layer B. Okay. Now let us define the load combinations. Of course, we will select the default load combination. We are not interested in service load combinations. Okay. Now let us run analysis and design. We will save this file. Yes. Here are the deflections. You can check how the deflections are. Let's display the slab design in both the directions. Show bars. The slab is only 7" thick, so let's just take this 4, apply. So here you can see the number of bars. All slabs are designed properly. The bars are shown over here. How many bars, dia, etc. Everything is shown. Let us run the detailing. Going to take little time. So the drawings are ready. We can have a look. Slab rebar plan, bottom bars. This is the slab rebar plan for the bottom bars. You can have a look for the top bars also. All details are there. Then slab sections are there. You can see the slab sections. In both the directions, it is there. Beam rebars are also calculated, which we are not interested in now because we have already designed this beam in our SAP analysis. We can check and confirm whether the results are okay. It should be, because the data has flown seamlessly. So this is the way we design the slab in SAFE 2016. So this is the complete way we design the foundation and we design the slab by SAFE 2000. Maybe in one of my another lecture or next coming lecture I will demonstrate how to design the mat foundation. So for the time being, this is the end of my presentation. So hopefully you will like it, and please do not forget to subscribe my channel. Your support, your appreciation is always welcome. Thank you very much. Bye.